The webinar this morning. I'm looking forward to going through this one. So this is a little bit of a short webinar, should be about 30 minutes. The why in AI. Thanks for coming along. Let's jump right into it. So I just want to say, giving this talk. I gave this talk before the pandemic and to a live audience. I haven't given it since, so bear with me if I'm a little rusty. I'm not sure how it will translate to Zoom, but we'll see how it goes. I hope you enjoy it. So, why am I giving this talk? What is this talk about? Well, interesting enough, this talk is really about me. Um, um, not in the sense of what I am about or who I am, but one of the key factors is I studied cognitive science, which is human and computer learning, way back in the day. Spent a lot of time looking at how humans and machines learn and so on and so forth. And now we've seen this explosion of AI, generative AI has come in, and I've seen a lot of hype around it. And what's interesting to me is some of the things we were wrestling with back then are still some of the things we're wrestling with now. We have had this massive hype in AI, and I just thought it would be interesting for me to give a little talk based on my background on that. So, what is my background? Well, I studied cognitive science way back in the day. I'm mainly giving this talk because I like it. That's why I'm giving this talk. It's a little self-indulgent, but I hope you learn something. And if you don't, next month we're giving another talk on what advertising, what ads you should have in the different stages of the funnel. So you're welcome to join us for that as well. And we can have a bit more of a tactical talk next month. But also I'm seeing a lot of mixed messages around what machine learning AI can do. And given that, I thought it'd be interesting for people to understand some theoretical areas of AI and to really get a handle on what it is the machines are doing and how you as a marketer or a person interacting with them can help to collaborate with them. Also, this is still my perspective. Um, I encourage you to critically think about it and to, if you have questions, please come back to me, ask questions, tell me what you think about the talk, what you think about my perspective on it, and we can go from there. So yeah, so I studied human computer learning, and like everyone who comes out with a degree needs to get a job. So I went into digital marketing, seemed like the best way to go. And then as digital marketing has grown up, we've seen way more, machine learning, AI come into the digital space, and I really want to spend some time talking about that. So. A little bit about Binary & Co. We started in January 2019, and we do digital advertising and analytics. I have put a link in the chat if you guys, I'm opening up my calendar. If you guys want to connect with me to do any digital strategy, please feel free to book a meeting. We open up about 5 slots for that. We always do at the end of these webinars as well. So, yeah, that's that. Um, so, so is what is AI? So it's a really interesting topic to say, what exactly is AI? It's a huge umbrella term, and now we're seeing people refer to AI over and over again. We're seeing them ultimately say, oh, we need AI. But what is AI? And ultimately, what people generally are referring to now as AI is this generative AI, it's LLM, multimodal system. So we can talk about that. But ultimately, that's not what you might think of as AI. AI is essentially anything that is doing a task that a human can do. So I asked this question, who are these two guys? So the first guy here is Alan Turing. He is ultimately the father of theoretical AI. And he's very important in the sense of being able to set a benchmark for what AI is. Oh, my screen is not sharing. Okay, 1 second. I'm just sharing my screen. Sorry about that. Okay. My apologies. So yeah, my screen shared. So this is Alan Turing, and then um, uh, uh, and he is known as the theoretical father of AI. But also, we all know the guy on the right hand side. He's Benedict Cumberbatch, and he's Sherlock Holmes. So, but why am I showing these two guys? Well, ultimately, Benedict Cumberbatch played Alan Turing in this film, The Imitation Game, and really, this film was about Turing's time at Bletchley Park, where he um, cracked the Enigma code, which was the code that the U-boats used to send signals to him. So the film wasn't necessarily about AI, but what's interesting is they chose to name the film The Imitation Game, which alludes to a paper that Turing wrote in 1950 called Computing, Machinery, and Intelligence. And in that paper, he set a benchmark for what he felt was artificial intelligence. And he asked the question, can machines think? Will machines think? And if machines can think, how do we know they're thinking? So he developed uh, a test, which later became known as the Turing test. But in his paper, he named it the imitation game. And what was the imitation game? Well, ultimately, the imitation game looks like this. In one room is a computer, is a machine. In another room is a human. And in a third room is an interrogator. And the interrogator asks questions to either room. Any questions. And after a certain period of time, the interrogator has to determine in which room is the machine and in which room is the human. And Turing said, if the machine could imitate the human so that the interrogator 50% of the time couldn't tell which one was which, then it was thought that the machine was thinking, was intelligent. Now, in 1950, when Turing wrote the paper, he said that there would be multiple machines being able to pass this test by the turn of that century. Now, I initially gave this talk in 2019, and I could stand up here and say, no machine has categorically passed the Turing test. However, last year, June 2024, GPT-4 was said to have actually passed the Turing test. 50% of people that interact with GPT-4 could not tell that it was a bot. It is a landmark time in AI that we've had after almost 75 years since Turing wrote his paper, a passing of the test. So the thing that interests me about that is that this huge landmark change in AI has passed and no one noticed it. No one really said very much. And that says two things to me. One, is the test really a test of intelligence? Does it really get over the issues that we have with AI? And to my mind, not always. And two, I have some conjecture about the test. They didn't do a side-by-side analysis. They just asked whether it was a bot or not, and people had to kind of guess. Maybe picking the rules there a little bit. However, the point being is that a lot of the reasons why that maybe the test didn't people weren't as blown away by the passing test was because we're still seeing some of the same issues with AI as we were before. So, and what is that? Well, ultimately, uh, um, why does AI fail the imitation game most of the time? ChatGPT-4 not included. And a lot of the reason is context. A lot of the reason is machines lack context. They lack the ability to understand the greater world view of what is going on. And an example of this I always give is a number of years ago, our daughter, she likes watching cartoons, and we have our TV connected to our Google Home, and we have it so that she can't autoplay episodes. So she got to the end of one of our cartoons, and she asked, "Hey, Daddy, can I watch the next episode?" And I was in the other room and busy. And so I just said to Google, hey, Google, play the next episode. And Google did. Google played the 2001 album from Dr. Dre, gangster rap album. Now, apart from showing bad taste in music, it perfectly encapsulates the issue that AI has with context. So Google didn't understand, the AI did not understand the context in which I was asking the question to play the next episode. It didn't understand the context was about TV and playing and playing the next cartoon. Also, on a wider context, it didn't understand that you don't play gangster rap to 6, 7-year-olds. Huge Achilles heel about AI. It's the why. Why are humans asking those questions? Why are those behaviors there that are hugely important? It's understanding that why that makes you able to understand how you can interact and collaborate with AI. So let's step back a bit, right? Let's step back a bit about how do machines think, right? And this is a huge area in AI. Like how are we getting our machines to think? Well, ultimately, there are two types of AI. There's implicit and explicit. And I'm going to go through these really quickly. Understand them enables you to understand their strengths and weaknesses, essentially. Explicit AI is extremely rule-based. An example, I'll give you an example. Like a chess playing machine is essentially a rule-based piece of AI. It looks at all the moves it can do. And then ultimately it says, okay, this is the best one. So it sees everything, kind of knows nothing. Implicit AI is the AI we're seeing more and more and more of these days, where there are models that are trained. And there are differences in those models and those are trained. So let's take a look at where those essentially break down. So how does an explicit system work? So let's take the problem. Is this a cat? So you want to identify a cat. So we know that a cat's covered in fur. We know that a cat has pointy ears. We know that a cat has long tails. And we know a cat has whiskers. So we tell the machine that. And therefore, it likes milk. So therefore, it can easily ultimately identify a cat. You can see that when you get to a large base problem of where the logic is fuzzy, explicit AI systems can fall down. An example of an explicit system in today's world would say be the Google search engine. Now, the Google search engine is explicitly told how to rank websites. If it has these keywords on it and it has this site speed and this many links pointing to it from this sort of domain authority, so on and so forth, that's the one you put at the top, explicitly laid out, which means that people can unpick that nature of the AI. Essentially, they can actually unpick how it works. This is explicit AI. It's explicitly doing something. That's not how other types of AI work. So going back to our little problem about the cat, implicit AI or neural nets work in an entirely different way. So they take the problem, is this a cat? And ultimately, they just show you examples. This is a cat. Yes. This is a cat. Yes. This is a cat. Yes. This is a cat. No, not a cat. And by training that model, by taking a neural net and training that model, you reverse the approach. You're essentially saying, give it examples of things that work, and then make the machine learn. You're using a recursive neural net to train the machine. So it's implicit. You can't exactly tell how the machine is understanding that this one is a cat and this one is not a cat. So reverse engineering implicit AI, reverse engineering generative AI is actually a lot harder because there's no hard and fast rules that you can say you've taught the machine to identify the problem, to understand speech, to interpret an image, to decode your website or whatever it is. It is a much more implicit nature. So there have been major steps within this area of AI and generative AI is really does take this on. And most importantly, machine learning algorithms for digital platforms and behavior recognition have really exploded. So understanding, like seeing patterns within data. I want to get this outcome. I want to get this conversion. Find me these people that will convert. You're not giving the machine the rules in which to find to convert. You're just saying, this is the result I want, go find it for me. And you're training the machine to do it through what is a recursive neural net. So where does generative AI fall into this, essentially? Where does it come in that great thing? So the difference between generative AI and maybe the AI that I looked at all those years ago is the technology is becoming stacked to further validate their use. So when you're looking at generative AI, it comes in layers. So ultimately, you have that initial input layer that decodes your text. It's a neural language processor. It's going to decode your text. It's going to say, you know, this is what this text is. It puts it into an array, and then it's going to push it through a data management layer that's going to tidy up anything that's not needed before putting it through a processing layer so that it can then come out with an answer, and then um, and then it's going to have an output layer. So, and the point being now is that you have these stacked systems that allow it to a decode, to a prune, to then orchestrate an answer, and then you are essentially coming out with an answer. However, and the thing I will point out is the structure of the technology is still essentially the same. The neural nets that I did 30 years ago, it's still the same neural net. It's still the same recursive neural net. It's not that much different. What they are doing now is being able to stack them and being able to have larger processing power with more data. More data, larger processing power, and stacked neural nets or lateral language processing um, uh, is really where we're seeing that greater advancement. And that's really where we are with AI. So what does that mean? So where do you go? Where do we come in? So I try to give a few examples of where we come in essentially as um here we go. So what is it that you as a human are able to give to AI to collaborate with them? One, so is data interpretation. And that is really comes down to that context piece, understanding what it is that enables you to see data and say why that is happening. Why are we seeing that in the data? The thing about AI is it may be able to give you some ideas, but it has to have seen them in a pattern before. Taking those leaps is really down to you. Now, there was an experiment done in 1980, which I want to talk about transferring analogies. So I'll go through, and I think this is important when you're looking at data analysis. So, for instance, um, um, the uh, the experiment done by Gick and Holyoake ultimately gave two sets of people the same problem. They asked them they said, you're a doctor, you're trying to cure a patient that has a tumor, you have a radio-free ray to go in, and it can take out the tumor, but it's too strong and it will destroy the tissue in between it. To half the group, they give another story before they're given the problem. And the other story is about a general who wants to attack a fort, but he can't go down. There's multiple roads into the fort, and if he sends the entire army down one of the roads, they'll get blown up. So the general then splits his army and goes down several roads. So it's a divide and conquer problem. The thing is, those people that are given the general story beforehand, before going to the tumor story, are better at solving the tumor problem because they have the analogy of divide and conquer before they can go into it. So humans are very good at taking a concept here and applying it here. Now, interestingly enough, about Geek and Hollyoak is although some humans were very, very good at some participants were very, very good at solving the problem, they needed prompting. Prompting is one of the things that help them understand the test. So I will say the act of data analysis can involve taking leaps. And I was trying to think, what is a real world example of this? And it took a bit of time to work it out. And we always give this example of Clayton Christensen's Jobs to be Done framework, where he did an experiment because McDonald's had come to him and said, we are seeing a rise in single serve milkshakes at 9:30 in the morning. And he couldn't understand why. And they sat someone in the car park and they asked them, why are you buying this single serve milkshake? And they said, well, I'm on my way to work and I wanted something to do. And I didn't know quite what, I thought I'd stop in and get a milkshake. And the leap that they're making here for this service of doing single serve milkshakes is that boredom was the value of milkshakes. Taking that leap and understanding that in order to assuage boredom, you're going to buy a milkshake is really where you're seeing that analysis of data. And much like the Gitkin Hollyoak experiment, they needed prompting. The interpreters needed prompting. They couldn't make that jump between why were the milkshakes being sold at between 8 and 9:30 in the morning and people are commuting boredom. They needed to make that leap. So what I'm saying here is the value you're going to get is by talking to your customers, understanding, making those leaps, seeing the data, but then taking that data back and talking to your customers and getting qualitative feedback on why those things are happening. Just sitting in your silo, looking at the data and trying to find out the why, not necessarily going to be as valuable as going out there and getting those prompts and doing that human thing of making that leap. So that's one thing. So the other thing is testing and expansion. So we had the interesting situation where we have a hotel. We do work for a hotel in London, and we have a number of adverts coming up. And what we noticed is headlines with secure parking, great transport links did well. They essentially got clicked on a lot more. Now, why is that happening? And we had to work out what was going on and why that was happening, essentially. So talking to the hotel owners and talking to the people that were in the hotel, they said, well, the hotel is out just on sort of outside of London. It's in Wimbledon and it's in Kingston, and the people don't want to pay the congestion charge, but they do want to drive into London. So they look for a hotel with secure parking. And then they park their car, they stay overnight, and then they take the transport links into London. The secure parking wasn't about, oh, I need someone to put my car. It was about the fact that they needed somewhere that was outside of London that gave them their access into it, essentially on an ongoing basis. So once you understand the why in that behavior, you can do the next thing, which I'm going the wrong way. Um, which is take your boring parking and tie it to the thing that people really want. So people want their secure parking because they're going to the theatre, they're doing sightseeing, they're going to restaurants. So you can also then go on and say, stay at a hotel, get vouchers for restaurants, get vouchers for sightseeing, understand and access the things that people want to make your next iteration of your advertising, your marketing based on why people are having that behavior. Collaborating with the AI and understanding that, yes, it's identified a pattern, but why does that pattern exist? And what can we do about it next? And the other third thing is I always say taking leaps. This is a bit more nebulous. I always say humans are much, much better at taking leaps than machines. Machines have to see it before, understand it, and then move it on. And then before they can take the leap. So if you're looking at something and you think that might be happen, go ask your customers, go see if you think you're right, and validate and take that leap. It's qualitative as well as quantitative data that's going to help you move your marketing on to the next level. Um, and that, I said it was going to be about 30 minutes. I think we're at 28. If you have any questions, yeah, let me know. Yeah.